We are now going to talk about functions. We could spend an entire semester talking about functions. We are not going to do that. All we are going to do is introduce you to the idea of functions and specifically the notation of what functions look like. So we have explored and looked at equations. Specifically, I'm going to reference equations that we would be graphing that make lines, linear equations. We've done a lot of linear equations, and our favorite form of a linear equation is slope-intercept form. We all are familiar with y equals mx plus b. And if we used real numbers in there, it might look something like y is equal to 2x plus 3. That is slope-intercept form of a linear equation. This form uses two variables, an x and a y. And we often relate those two on a graph, the x-axis and the y-axis. With functions, we change our thought process a little bit, even though the idea is still the same. Instead of y equals 2x plus 3, we might write it as this. In place of the y, we write an f followed by parentheses with an x inside it. The rest of the equation is still the same. This does not mean f times x. It kind of looks like you've got a letter f and a letter x, a variable f and a variable x, and they're being multiplied. That is absolutely not what that means. We say this f of x. That's the language we use when we see this notation. And in what we want to do is think about it really in terms of inputs and outputs. Here's what I mean by that. I'm going to make a little XY table like we've done before. And we're going to focus on this equation that I gave you to start. We used this when we were first introducing graphing linear equation. So give me your favorite number. I think I heard 1. Great. So let's pretend that our x value is 1. And we use this equation, y equals 2x plus 3. We're going to input 1 right there. We're going to stick a 1 right there and calculate the y. 2 times 1 plus 3 is 2 plus 3, which is 5. So if we put a 1 in, our y is equal to 5. We get a 5 out. Give me another number for x. Oh, I heard -2. Thank you. -2. So let's say x is equal to -2. So y will be equal to 2 times -2 plus 3. 2 times -2 is -4, plus 3 is equal to -1. So if we put a -2 into our equation, we get a -1 out. One more. Let's do something big like 10. Let's say x is 10. Y is equal to 2 times 10 plus 3, which is 20 plus 3, which will give us 23. So if we stick 10 in, we get a 23 out. This is the idea of inputs and outputs. X is always going to be our input, right? These are the numbers that we're going to be putting into our equation. And then y, we think of as our outputs. We put this in, 1 in, we get 5 out. And then that tells us where to go up or down, okay? That's the idea of functions, but the notation just changes. Instead of y, we are now thinking about it and saying it as f of x. The function, the name of the function is f. X is going to be the input. So whatever number I put in here, it's going to tell me the value of the function at that input value. It's going to tell me what the y value is. That's what function notation is. So here's what it might look like. in another, maybe more simplified form, it might say, find f of 2 if f of x is equal to x squared minus 7. So this is saying we are going to calculate the value of the function if x is equal to 2, if this is the function. So we're going to say f of 2 is equal to 2 squared minus 7. We'll replace x with 2 here. That's going to be 4 minus 7, which is negative 3. So we would say f of 2 is equal to negative 3. Some other language you might see using function notation is this. The function h, because we can name it something other than f, g, h are common letters. The function h is defined by the following rule. H of x equals negative 2x plus 2. And then you might be asked to complete the function table. This is really the same thing we did a couple minutes ago. Here would be your x column, but instead of y, you'll see h of x. And then you might have several values here, negative 4, negative 1, 0, 3, 4. And you would have to calculate the value of h of x for each of these numbers. So you might say h of negative 4 is equal to negative 2 times negative 4 plus 2. I got that from up here. Negative 2 times negative 4 plus 2. That would be 8 plus 2, which is equal to 10. So again, if negative 4 is the input, 10 is the output. Inputs and outputs. We could keep doing that for all of those values. Now, there's a couple other terms that go along with these ideas of inputs and outputs that go along with functions. When we're looking at a function, all possible inputs are called the domain. All possible inputs are called the domain, right? So for most of the ones we've looked at so far, we could put any number we want. I could put any number I want into X right there. Okay, I could put any number I want. So the domain is really everything. It's all real numbers. All possible outputs any numbers I could get in my output column, those are called the range. So where might this idea of domain and range actually come into play? Let's look at this one. If g of x equals x squared minus 36 over x squared minus 64, find g of 8. So here's another way that a function problem might look. It's defining what the function is. It's giving you the name g of x. And then here is the function rule. Okay. Then it's saying, here's what we want to evaluate. We want to find g of 8. 8 is the x value that we're going to substitute into this equation. So this is a rational expression. So we're going to do g of 8 is equal to 8 squared minus 36 over 8 squared minus 64, which is 64 minus 36 over 64 minus 64, which is equal to 28 over 0. And we know anytime we have 0 in the denominator, that means it is undefined. That is undefined. So what that means is, and we've talked about this before, you know that rational expressions, because they have variables in the denominator, sometimes have restrictions. They have values of x that are not allowed to be used. That means they're not part of the domain. We can't use them as an input because they would cause a 0 in the denominator. They would cause our fraction to be undefined. So in this case, that would happen for both x is equal 8 and x is equal to -8. Both of those would cause this denominator to be 0. So basically, that means that the domain of this function would be all real numbers, except x can't be a to -8. It can be anything else, but it just can't be a to -8. Okay, that's where this idea of domain and range comes into play. Let's look at a couple more ideas of functions, but with graphs. Okay, so we're going to think about the ideas of inputs and outputs, except look at how they are related to graphs. So here is an example. What you see here is instruction. It says the graph of a function h is shown below. And you see the graph here. You see the line, right? We see this line right through there. And then it's saying find h of 2. So if we think about what that means, find h of 2. 2 is the input. 2 is the input, and the input is always going to be the x. So the input is x. H of 2, that's going to be the output, and that's going to be the y. So basically, this is saying in this graph, if x equals 2, y equals what? That's another way to interpret find h of 2. So what are you going to do? You're going to look on your graph and see where 2 is the x value. Look on your x-axis. There it is, right there. So if this is the input, 2, what's the output? You're going to look over to your y-axis. What's the y value there? The y value is equal to 0. So we say h of 2 is equal to 0. 2 is the input. 0 is the output. One more way we can examine functions using graphs would be like this. There is one more. So this one says, the graph, let me make this a little bigger. The graph of a function f, so there's your name, it's called f, is shown below. And then there are two separate questions. The first one says, find one value of x for which f of x equals 2. This is a different question than the one before. Find one value of x for which f of x equals 2. Let's examine this statement. F of x equals 2. X is the input, and this is the output. So think about what that means in terms of x and y. X is what we're looking for if the output y is equal to 2. So here you have to look at where is the y value equal to 2. Find your y-axis and find 2. It's right there. So look all along this line here, right, where y is equal to 2. And does that hit your graph anywhere? Yeah, it hits at two spots. One is right here. Let me make this a little clearer. One is right there, and one is right there. You were told to find one value of x. You have two options. What are they? Take this point and just trace it back down to the x-axis. 1. That's one of your options. So you could say f of 1 is equal to 2, right? If x is equal to 1, y is 2. If the input is 1, the output is 2. And also trace this down to -2. F of -2 is also equal to 2. If x is the input at -2, y would be the output at +2. So find one value of x. You could either say 1 or -2. Either one of these would be appropriate. And then this second part of the question is the same as the previous question. Find f of -1. F of -1, -1 is the x value, which is right here. So we would trace that up or down until we hit the graph. That would be right here. And then we would trace that over to the y-axis at -4. F of -1 is equal to -4. So this is the idea of functions, their notations, how we evaluate them, how we look at domain and range, and how we can examine them using graphs.